Hi, good morning, good afternoon, good evening, ladies and gentlemen, and friends all over the world. And I'm honored to have this opportunity to speak up to talk about the active and the learning and in engineering education and with you today. So there are many ways to do that. And what I'm going to talk about is the one and I'm using, and I feel it's pretty easy to do. This is Jun Zhao and from mechanical engineering and from the Penn State University, the Barron College, and which is at the United States of America. Before I talk about details, and I want to give special thanks to my former colleague, which is Professor Bill Asher. And what I'm going to present today originates from his previous work, and also from many discussions and with him, and which I benefit a lot. So now I'm going to talk about in the active and the learning and the passive learning. Okay, so active learning is better than the passive learning, right? And through numerous researches, and also you can find, and which is true, and according to the many people's experience. So. But the reality is, and we know, and the active learning is better, but the reality is, and the lecture still remains a heavily used teaching technique, especially in engineering courses, all right, which requires a lot of the mathematics and the physics. So this is a typical and the process and for classical and the lecture, which is teacher try to and grab the book, try to read the course material text. So then try to process those informations and then try to rewrite the informations and then add some additional informations, for example, like examples and such, and then eventually and deliver the lecture and to the students. Could be a 50-minute long lecture, could be an hour and 20 minutes long. So that's a typical process and for teacher. So then for the student, they copy whatever on the boards, on the whiteboards, blackboards, PowerPoint slides, and that's it. That's the entire and the learning process. So for this one, typically students spend majority of their time just copy the notes instead of thinking what they are writing. So this is the fact. The fact is, this is a traditional way. I assume a lot of people are still following this path. So the teacher is actually doing the most of the learning in this process. Although teacher's teaching, but actually teacher is doing most of the learning in the process, not the students, and supposed to be the major one to learn. Okay. So why not? You may ask. Why not? We know about that, right? Why not active learning? We know the good things. We know the, it's a better one. And we know the, disadvantage of the traditional lecture. Why people are not doing that? So there are many reasons, okay? I just listed some typical ones, I think. So the first one is, as a teacher, and that's on our mind, we need to cover all the necessary materials in a short and let's say typically in the United States and the 50 minutes and the period lecture. So lecturing is efficient way. Why it's efficient? Because it's more organized, right? And so it's efficient. So it's a good reason. The second one will be, to be honest, that could be on faculty member and has a limited knowledge and about the active learning and the methods, and especially and if you like the junior faculty members, and we talk about, okay. The third and but not, I'm not against the junior faculty members. It's just by reality, right? You have less and teaching experience, and so you have the less time to experience those things. Okay. The third will be we might have, as a teacher, we have the concerns and on the amount of the time it takes to develop those kind of learning activities. All right. Oh, maybe I got, it takes too much time, too much effort to do that, right? So in theory, so it sounds interesting, good. But in reality, I'm not going to do that. All right. I just listed some of the, I think the typical ones. You can add into the list and more. Okay. So the solution. So we said that we engineer and we are a problem solver. So we notice a problem. We try to propose a solution. So one of the idea is, how about let's reverse the process, right? Let the student teach and let the teacher do the evaluation. So, right. So in this way, students can be the major learner while teaching, right? But it sounds great, but it's not practical. So why it's not practical? It's because it requires, if you do things in this way, let the student teach, he needs to do all the things in my previous slides. So he probably needs to spend excessive preparation time, even for very good students, right? Just based on the topic. And in the engineering courses, and normally a lot of the technical stuff that might require significant amount of time for the student try to pick up those things totally by himself or herself. Okay, so that's why it's not practical. So what I try to present over here. So since it's practical, how about let's make it practical? Okay, so this is my method, the current method we are using at the Penn State and the Barron College. So we're going to ask the students to read and process information before they come to the class. Okay, and so then we can use the class hour and mainly for discussion, for asking questions and for answer the questions. So that's what we try to do. So just in a second, I'm going to talk about how to do that and the details of this proposed and the method. Okay. So this method, it's very easy to do. It's doable, and the reason why it's doable is because at the current time, noticed and the quality of the engineering text has improved dramatically. And now they are accessible to the average undergraduate students. So no issues at all. The textbooks are different. So those and the authors and the editors, they spend tons of time and effort. And so now, so that's the reason. And the quality is getting much better. And for the undergraduate students, okay. And it's doable now, okay. And also it's been a standard practice in some non-technical and the courses, right? Like the literature and when teacher teach the courses, the literature and the courses, okay? So it's been practiced. So we borrow that one and into our engineering education, okay? So the motivation for this and the method is we try to improve the student learning. That's the single goal and on our minds by doing those. So, and why can? So those are the why. Students can learn the easy material on their own, as I explained to you and in the previous slides. So the save time can be used for more in-depth learning, all right? So that's why, and it can improve the student learning. Another is, and the students can be actively engaged with materials by reading assignment. You give them the reading assignment and you force them to read. So they are more engaged and they take the lead. They're taking the lead. So and also the instruction now is focusing more on teaching students how to read and how to understand the text. So this is more useful skill, like a lifetime and skill for lifetime learning. Okay, the benefit them not just short term but also long term. So the last will be using this and technique. You're going to have a more fun classroom, all right, because we have more interactions with the students, all right, and obviously, and you're going to have the better evaluation from your students. Okay. So what's really the active learning? We're going to say, I don't know that there is any, I'm not sure whether there's any official definition, but there's a lot of the writings and on that. I put some of the one and I like, and so like, for example, like this one. So like from the Chickering and Gamsung, and so for students to learn they must do more than listen. They must be engaged in higher order thinking tasks such as analysis, synthesis, and evaluations. So those are the key ingredients and in the active learning. So I like the teaching strategy. Actually, you cannot simply just say they are passive or they're active, but instead it's a continuum and based on continuum between those two. For example, so lecture can be active. We think in our mind, traditional lecture is passive, but it can be active. And by, for example, buying, and during your lecture, you buy, let's say you have every 5 minutes period or 10 minutes period, you do some kind of like activities like the adding the asking questions, doing the clicker questions, stuff like that, okay? So lectures can be active. Homework in general, and by assigning the homework, let students do the homework on the homework. We think this is an active way, this is part of the active learning, but it can be passive. If just students just say, oh, I go to my book, I found the equations, I plug in the numbers, then I try to do that without much thinking, that's not active, that's still passive. So as I said, so this is the key things about active learning. And to my understanding, I think a true active strategy is the one that requires students to critically think about the issues. Okay, to critically think about it. For example, like the ways like, and you can have the group discussion, problem solving, case study, in journal writing, and so on. So those are the different modes of the active learning. You can add some more. So, so for this proposed technique, so here we are not assuming students know how to read effectively. That's the pre-assumptions I'm using. And they must be taught. So you cannot completely just say, hey, you're going to do that. I'm going to sit, I'm going to watch. As I mentioned, it's not going to work, it's not practical, okay? The second, the presumption will be, so when we prepare for those, we must include in the specific actions that students can take that force specific thinking, instead of simply reading the material at the superficial level. You just randomly, you say, I'm going to give you the questions, you're going to answer those things. No, it still requires the important and the contributions and from the teacher side. Okay, just in a second, I get into the details. So now I'm going to briefly describe the techniques, these techniques. We are engineer, we do things in structured way. So those are, and typically what we do in our classroom by using this technique. So, so first, you have to read the text and make notes of all the important issues, or the issues as a teacher you think is important for the student to learn. The second, you can identify number-wise. I just put some numbers over here. Depends on the topic you're talking on that day. So this is typically for our 15 minutes lecture, and we identify 5 to 10 key issues or questions, and write the questions and for student discussion. Okay, that's typically. So then, oh, sorry, I should be in step 3. Give questions to students in advance. You have to give these questions and in advance, beforehand, at least one lecture and earlier. The sooner the better. All right. So if you get all the things done before your semester starts, that'd be super. Okay. But give to them as soon as possible. Don't just say, hey, at the beginning of your lecture, say, oh, those are the questions I'm going to ask you to, and to answer. That's too late. So they have to spend time to do the pre-study according to this question. So then in your class, you can call individual student and to answer specific questions and in their own understanding. Okay, when they answer the question, make sure they don't just repeat whatever from the book. They have to interpret it in his understanding or her understanding. So that's pretty much about typical and the lecture for this technique. So I use this one, and for my teaching of a senior undergraduate tech elective, which is a computational fluid dynamics, which requires a lot of the mathematics and the physics and the understanding. So I did the 3-year study, compared to 3 years of study if the results over here. So the year 1 over here, like the blue bar and shown in the figures over here. So year 1 and what I do is year 1 is without using those and go with the traditional and the lecture. And the year 2 and the year 3, I go with those kind of like the active and the learning technique I presented over here. And only for year 2, I only did that one, and for the active and the learning, and after the first exam. Year 3 for the whole semester, and for both of the exam 1 and exam 2. Yeah.
1 minute left for your presentation.
Sure. Okay, I'll present quickly. So, and the exam 3 and the entire semester. For both exam 1, exam 2, I use this active learning. So you can see the results over here, which is the green bars over here. And the red bar is for the second year. So you can see, and the obviously you can see over here, since I don't have enough time, so these pictures it's pretty clear for self-understanding. If you have questions, let me know. You can clearly see the active learning, and it can improve there are 2 scores over here. One is the average score of the exam, and the second one is the median and the score of the exam. So you can clearly see it's improved a lot, improved about the active versus the traditional, improved about the 15%. So that's a significant improvement into the students and the learning outcome. So the results over here. So actually we find out the present and the technique requires less work, and then preparing for traditional lecture. The materials will cover the same, even for faster speed. Okay, so that's what we noticed. And the students, obviously, performance is better evaluated. Sometimes students just take the shot, last minute preparation, go to the exam, and they got the nice score. But that's not the fair evaluation for his performance. But by using the active learning, you interact with them, you know their performance better. So, and also the present technique is more enjoyable way of teaching. You have better actions with the students. But so here for this technique, it assumes the instructor to really know the content. If you don't know the content, it could be a different story. The second, the approach assumes that the truly good text exists for the course. You need to pick up the right book, right, to let the student read. Otherwise, if you pick up the different book, that ends up in the some situation or work. Third, some students like it, some don't like it. For example, some of the reasons, and the not good for certain type of student. Some students have difficulty with the lack of the structure, and they're more like the traditional structured way. So it requires students to actually do the reading and to be prepared for the class. You have to figure out a way to force them to do that. If you don't do that, just come to the class. It's horrible. So, so this is a conclusion. This technique is very easy to implement and to encourage students to learn the text by themselves. And also it's a good way for you to lead the discussion class. It's effective in improving learning and make classroom more fun. And also, pay attention to here, that this technique can be effective, but must not be overdone. You have to be very careful. You just say, maybe you just say, hey, for certain weeks, I'm going to use those, not for the entire semester, until you can handle those things and completely by yourself. So first, it should be also effective in non-engineering courses, such like the mathematics and physics. Okay, so the nature of teaching those courses are the same as teaching the engineering courses. So that's pretty much what I want to talk about. Thank you. Yeah. So any questions?
My topic, transforming education using learner-centric approach. This is the work on which we are working, I and my supervisor, Dr. Slamal Kumar Das Mandal. He has been working in this field for 2 decades till now, means from the time when learner-centric approach has been worked. And speaking about our department is Advanced Technology Development Center, IIT Kharagpur, India. And our department actually works on doing a different type of educational instruments or pedagogies or like teaching learning process. And IIT Kharagpur is a very renowned institute of India, and like we have very good alumnators all over the world from our institute. And this is all about. Okay, so why we need to go for the learner-centric approach? Traditional approach till so many centuries was working so well. What's the biggest challenge? If we see that we need to work, what we need to face in 21st century, that's very, very important. And what are the things we are getting in 21st century? 21st century is a century where we are getting technology at our hand. Now we are using in India, we are using 4G data network. Internet is used for simple pronounce a word also you're using internet. So when the technology is so handy, is we find very difficult to make the learners engage throughout the time. They feel like if they work for a month before the semester, they can do it, and they don't feel interesting in the class too, because the information delivered by the instructor or the teacher or the lecturer is the information which is broadly available everywhere, maybe in a video mode, maybe in graphic mode. So almost learning is a boredom work nowadays. But education is a vital part of the society. If education lay behind, society cannot move forward. So we need to face the challenges of this century. First, what we need to understand, we need to understand the students or the learners, they should be engaged throughout the semester, throughout their teaching learning process. Second, we know that before 20th century, gaining from our environment was a major task, major goal. But now it's not only gaining, but we need to have sustainability, so that we can, this process, whatever we are getting from our environment, from our society, can be given back also. So it's not only the knowledge, not only the technical skills what we need from the student, but we also need the attitude, the soft skills, how they need to interact with the variety of uh, co-workers, variety of pioneer members. So that's also very important. Then again, if you're developing any curriculum such a manner that they will be engaged, they will also have the domain independent and dependent knowledge, skill and attitude, then also that infrastructure that's need to modify it so that it can be used in future also. It should be also open up to all the stakeholders, coming from this learner, the teacher, the curriculum designer, the industry peoples also, so that it will be a complete frameworks, which by following which a student can understand the need or what is desired from them. Again, when we're designing such a thing, we need to understand that there should be an examination system which measure all these parameters. It's not like we are saying them to understand that they need to acquire the skill. They need to acquire the domain independent and dependent skill. They need to have the attitude, but there is no examination system or no assessment system to see that this is happening or not. Then also they will not feel motivated. Again, as we know that every technology is updated in daily basis. So if in order to be always industry friendly, the students should have a habit of learning throughout their life. They should become a lifelong learner. So how to make them, how to encourage this characteristic of the student of learning, that's again a big challenge. And most important overall, to sum all the challenges together, when you're teaching, we're teaching in a bigger classroom, a classroom where we have more than 60 to 120 students at a time. And when we're addressing them and addressing these challenges, how to go hand in hand, because we have a limited time, we cannot extend the time. So what's the way we can face it? There are many learner-centric approach in these 2 decades, starting from the 21st century. And these are really very effective. They understood one thing, that the traditional way of teaching will not work. Traditional way of teaching means the teacher deliver the lecture and the student listen passively, carry out the notes and go home and read out the notes. This will inculcate, this will make them, or this will trigger their lower level of thinking skills. They need to have the higher order things skills, as Professor John has already said, that they should have analysis capacity, they should have synthesis capacity, they should have evolution capacity. So if they need to trigger these all things, then the approach should be changed from teacher centric to student centric. We should put emphasis that how the students will learn. What's the process? They will take the responsibility of their learning. How it's not important what teacher teach, but it's really very, very important that what the students learn. So there are many in this time we have seen there are many learner-centric approach came on the surface. Like first, let's speak about the flip teaching, as it's really very interesting and very encouraging learner-centric approach. Professor Joe, what the teaching learning process, what Professor Joe has already shared today, is flip teaching. Here, basically, what happens that the students has been said that what they need to prepare for the class, they read it, they prepare, and they come to the class. And classroom should be a discussion class where the students share their problems, what they came across where learning the substance, or how they have tried to relate it to the real life problem and they could not. And again, their friends are encouraged to share that how to solve the problem. They are encouraged to clear the doubt first. When the students are not able to clear the doubts among themselves, then the instructor or the teacher take part. The work of the teacher over here is to make everything to control everything. He sees that the thing is happening in positive manner or not. When we are following the flip teaching, it's really make a good bonding, because the students, they participate, they discuss, they develop the communication skills, they know how to deal with the students, how to deal with other person. They also feel that they can also promote collaborative learning also. But there is some problems over there also. Like it's very difficult to understand that what is the pre-classroom learning. Did all the students have learned it properly, or they have just like Professor Jao has also shared it so nicely, that if they have just gone through the thing superficially and came to the class. Again, another problem is over here is that sometimes it happens the students don't understand that what exactly is needed for them to learn from here. They find it's very vast, because we cannot say that a single definition, a single word can say that how much to learn. There should be proper definition how much to learn and what extent they need to learn. Coming to the next type of learner-centric approach is game-based learning. Game makes everyone feel interesting. Every students, maybe from LKG to the senior undergraduate students, they feel that game is really very interesting. So there are many researchers working on this place also. They use game mechanics, or they use like game like things, like if you complete one assignment or one means like a question answer round, and if you are scoring good, they give a like a score, they give a medal, they give a trophy sort of thing. So it happens, it encourages the students on learning. But again, it's really very difficult, because when we are saying a game based learning, here the educator need to define it, design it very properly. And for each subject, with every change in the subject, in the module, in the course structure, the game need to redefine. And they should understand that they are completing a syllabus, they're completing a course, they're not making only making the student feel interesting. And the students should also understand that they need to learn something from there. It's not only playing games. So like it's sometimes it happens that the learners feel like they're living in the real world, not in the real world. Again, like the time constant and the use of gadget, the executor designing the game is really very challenging task. So it's also very difficult to do for every subject, every course, every domain. Coming to the next learner-centric approach, the project-based learning. Project-based learning can be done for a course together. Here, basically what happens, the educator or the instructor gives a definition of the problem, gives to the students, and they find out a solution of the problem. And this is done in group. So when they're doing in the group, like the domain independent skills, what we say, like communication skill, the skills how to deal with other people's, other race people, the different culture people, they can learn from here. Again, if they're doing project based learning, then deep learning is very important for project based learning. Again, so the time constant is very important for that. Again, sometimes it happens that the instructor also should understand that what the learners or the group is doing. If the instructor is not able to understand or capture the route or the direction in which the students or the group is going, also it's very difficult to apprehend. It's very difficult to assess their learning of different type of groups and different type of students, because it happens also in that in one group some students, they do not take participate, but they earn the score by their fellow members. So that's also very important. Again, if we're not designing a proper curriculum, we cannot assess the learning of the students. Also a proper curriculum is also important. Coming to the like another very important learner centric approach, like scientific argumentation. This is also really means in the coming in the picture in last 2 decades. So here basically what happens, the student, it's a discussion way where the students are encouraged to discuss on some real life phenomenon with some scientific argument. So this is very nice to develop their domain independent skill. But at the same hand, the instructors who is doing the scientific argumentation, who is taking the lead in the scientific argumentation, they should understand that the argumentation should never go to the negative direction. It should be really the instructor should be experts one. And like it's again you cannot say that by scientific argumentation all the courses can be followed, or it is not suitable for every domain of like courses, or maybe you can say like engineering field, or like it can be applicable in one field but cannot be applicable in another. Then coming to the next part, which is really very, very important, which I really want to share much more, is my outcome-based education. Outcome-based education is a proper structure framework where the course is properly defined, so that students, before going to the course, going to the even the program is also so well defined that they can understand that I'm going for engineering career and I'm going for computer science engineering, means I'll be knowing this thing, that the learners know it pre-hand. It's not like that when it happens mostly before when students complete the schooling, he asks that what should be my field, which means major subject I should be taking, and he follows that, yes, my uncle's aunt and has all has are from this background, so I should take. But when we say that this is outcome based education, the learners know that why he need to choose this, and after choosing this, what is expected from him. That's really very, very important. And this is the first step when the learners understand that he needs or she needs to understand or learn these skills, or in some way takes the responsibility of his or her learning. It's very, very important. Then it's improve the learning effectiveness, the quality also. But sometimes if you see the past literature, it happens that outcome-based education is very good for the domain-dependent skill, but domain-independent skill is somewhere left behind. Again, the same problem, the problem what we have discussed from the pre-hand in the first slide, that what are the challenges of 21st century. Here also this outcome-based education somewhere failed to engage the student throughout the course. So there should be some change in it. So some modification in it so that all the challenges can be met properly. Then there's a hybrid mode of learning, learner-centric. Here basically one or two way of teaching learning process are mixed together so that learning will be better. Like we can say MOOC, where the traditional teaching is add with the online platform where they give assignment and assessment is done in the online platform. Then also that's also worked very well for online learning process also. Again, there are some challenges what we need to understand when we're going for the blended learning. First, we need to understand that blended learning means two process of teaching learning process should be mixed properly so that the students should not feel that there is two different course. They should feel that this is one course and in the two mode. Again, they should not increase the workload of the teacher, or they should not increase the workload of the teacher or students. So proper planning should be done. And we should not use so much of technology that there will be risks of failure. So at last, what I conclude over here that we need to have a curriculum so that the learner-centric approach should be properly developed. And now again, what's again next challenge what we need to understand? We need to understand that we need to make the course interesting. We need to make the students to understand that what is needed from them, and that should be done properly. That should be done in each classes. It's not at the end of the semester. It should not be at the end of one class test.
Finish.
20 minutes is over.
Yes, you can wind up in a minute. Yes, Professor William is waiting for his time.
So give me 2 minutes. So what's my objective? What I have doing here is to design a IT-based framework where a outcome-based curriculum is designed. It also has self-learning material and assessment so that when the students get the curriculum, he understands what is expected from him, from where he will study, and after studying, he can assess himself or herself by doing the practice problem or assessment. This is the total thing of an outcome-based education. I'm just trying to wind it off quickly. So what I'll be having here is that I'll be having the course name, course overview, where what the course will be doing, will be getting course learning outcome, course practice problem, course module. Course module again have module overview, module level learning outcome, module practice problem, and each module has the module learning materials from where the learners will learn. Again, each module is defined into module lectures. One lecture is, we have here 1 hour of class. The one lecture is one class where we will be giving them lecture summary, what we expected from that class, and lecture level problems. And we should, as we all know, that all the objectives should be specific, measurable, achievable, and doable. It's also have the 3 components like the performance, condition, and criteria component. And like this is a very simple, the first design curriculum where we have for the course basic electronics, we have written the course overview, course objective is written here. They are basically in higher, like because this is a very primary subject, so this goes to the higher domain like analysis. Then the practice problem addressed to it also is there. You see here is written the objective linked to the problem number. Problems are objective 1 and 2. This test item addresses objective 1 and 2.
Okay.
Then we have and the course material. And so the total thing has been done. And we can see that if you see the cognitive analysis, the course objective are in the higher domain, and unit objective are toggling from lower domain to higher domain. And we have this is the thing what we do here, we give it beforehand, and the class will be like summary. First class will be a discussion class. The first 10 to 15 minutes is taken to sum up or wind up the thing what is there in the what should be there in the lecture. The rest term is used to interact. It is done for a group of students. We have one total class was having 56 students. We have divided into two part. One has 27 students. We have given the process. We have done it for 8 lecture hours. Then we have seen that by using the outcome-based framework and flip teaching, their mean and standard deviation both are higher as compared to the control group. So what I conclude over here, that this proposed methodology works successfully in a large classroom. Learners know, they take the responsibility that they need to learn by themselves. It also helps them to gain the domain independent and dependent skill. But again, we need to have the framework what we have designed is a is the online framework which everyone can use it. You can also view it if you see the site. If you need, you can message me or you can email me. I'll be giving you the site. But again, some modification is needed there so that we can see that the objective are well written or not. Thank you so much. I hope in future we'll interact more. Thank you so much.
Managing projects successfully in a world of uncertainty. Is that the second one?
Yes.
Yeah.
Yes.
Okay. So where I'm going to go from is building on the last couple of speakers is a few points that struck me. The first is aiming at the 21st century knowledge and skills to make industry-ready engineers. So if we finally have that focus right, to be an industry-ready engineer, you first have to ask yourself, what is it that these different services and manufacturing and industries need from our engineers based on they've left the classroom, whether it's bachelor, master's, or doctorates, they are now in the workplace. And so, in my opinion, the classroom degree is not a destination. The workplace is the destination. And so the measure of a successful educational program is what gaps, if any, exist between what we equip our engineer graduates to do and what's expected of them in the workplace. So I'm going to be presenting reflections on exactly that question. What do people, engineers in the workplace, run into that may have caused them to fall short in their performances because of the lack of certain knowledge that education could have provided? For example, project lifecycle phases, proposal, negotiation, contract, initiation, dialogue, plan, execute, close. So what skills do they need? Well, of course, they need the engineering courses, but what they also need are knowledge and ability for collaboration. For example, to put together clear, articulate, and agreeable goals, priorities, deadlines, tasks, risks, and a timeline. To implement those plans into action, knowing you're working with people, not machines, but people who know how to use machines. How you monitor their performance, results, and decide next steps. And their ability to communicate effectively and efficiently, not just with the people they work with, but with the client, regulatory agencies, and stakeholders. Next slide. Human systems engineering is supposed to be the next one, right after the one I just discussed. The one right before it I just discussed, managing projects successfully in a world of uncertainty. The next one is human systems engineering. Is that okay?
Yeah, it's on screen.
Okay, so this was something that I derived when I started my consulting practice within the engineering profession back in 1986, 87, and it continued as a quality system consultant to engineers until 2004. And what I discovered was we have to look at engineering human systems, the application of organizational socio-cultural psychology to understand human relationship dynamics that are connected within and between projects, organizations, and individuals as it impacts the successful achievement of stated organizational, project, and individual goals. In other words, due to the expanded society across our planet and people from so many cultural backgrounds that have their own, they're not right and wrong, they're simply different from different cultures. How does that affect our interaction in project work? And so one of the things I use is which part of this watch is least important. Do you see that?
Which one you want to play?
It's which part of this watch is, it's the very next slide.
Yes,
It
yes.
shows the inner workings of a watch.
It's there.
It's there?
Yeah.
Okay. And I use this for those of you who are probably under the age of 40, it may look weird, but those of us who are somewhat ancient in age, this was what, if you opened what they'd call a grandfather watch, which they carried in their pocket, and you open the back, this is what you would see. You would see all of these wheels and little pieces of pinions and rollers, a lot of parts. And I suggest to you, this is what an engineering organization in the industrial and private and service sector world, this is what the organization looks like. Each of those springs and wheels and coils ought to be so tightly arranged and ordered and oiled and fixed and maintained that the watch tells time, and it tells time accurately. I compare that to a project. The project has dimensions for these parts, and at the end of the project, it's supposed to come out just the way this watch told time. So I raised the question, which of these wheels, small, middle size, bigger, which of these gears are more important than the other? It's an obvious question to an answer. Each one is equally important, but do we equip our people in the design industries and professions to see everyone that way? I'm on the next one. Here are some of the things. It's called a survey of management conflict within professional design engineering firms. Are we there?
Yeah, it's there.
Okay, so I went into these companies, engineering organizations, and to be clear, I went, frankly, across the United States in many areas, across Canada from Vancouver to Halifax. I did work with a firm in Tokyo, in Seoul, Korea, and in Manila. I did work in different cities in Mexico, always with the same people audience, engineers, architects, in the business of professional design services. And I took confidential surveys of their feedback. I call it listening. So I got the voice of the employee because I sat down privately and listened to them. I have the voice of the client because I went to their clients and listened to them. And just look at what some of the things are that employees are faced with in the engineering companies. They're concerned about saying something that they've learned for fear of retaliation from the management. There's a lack of internal teamwork. We keep calling these project work groups teams, but unless there's evidence of teamwork, stop calling them teams. You're not a team until you're working like a team. So yes, you have to develop from a group of talented individuals into a talented team, but it's not something you do by changing the language. The reward system for performance is quite unobjective. Company standards are not managed. In some places, the standard is whatever the project manager decides it's going to be. And interoffice cooperation across the engineering groups is quite low. And where it shows up the most, I'll just make an example, is when you get, for example, a civil engineer, mechanical engineer, structural engineer, and in the same room on the same project, talking about something that doesn't seem to be working well. their first reactions are to say their discipline, their profession from school is right, the work we've done. So you folks must have done something wrong. And so naturally today, we have a proliferation of books and seminars on conflict because they haven't learned how to take differences of opinion and resolve them. No one ever taught them that. Then you go to the voice of the client, where I interviewed clients. Clients would say things like, look, maybe we're not in, and I'm only talking to executive level. Clients expected to be more involved. Listen, I'm not an engineer, but I have opinions about some of the things going on. And you fellas, the engineers, seem to think you have all the answers. Engineers are bad listeners. I asked this question, and you don't have to respond. I ask engineers the question, when is the last time you told somebody of a concern, and before they attacked the concern, they said to you, gee, that's interesting, Sally. Can you tell me more about that? How frequently has anyone ever said that to you, another engineer? Exactly, almost never. They go immediately into their opinion from their engineering perspective. There's a lack of quality assurance and quality control before they submit work to other groups and even to clients. And when they notice a problem, it's quite late in the project's development. And obviously, there's a lack of interaction participation early enough in the project sequence, the schedule, to make any real difference. Next slide. So what do I suggest? How, when, why, what can we bring these so-called soft skills? And I just love that expression. We learn after we get out of college, within a couple of years of working, the so-called soft skills are really hard skills. And the soft skills are our mastery of engineering work within our discipline. But when are we going to bring that into the 21st century education in engineering degrees before they leave the school? Well, the answer I suggest, just a place to talk, not a unique solution, is adopt a model that others in education have used successfully. Next slide. I've given you the link that you can check out in your leisure in the Baldrige, the Malcolm Baldrige framework. They have a set for education. And if you click the link, you'll see no shortage of open-ended questions, not telling you what to do, but first asking you, what are your experiences with these issues within your educational system? And then after that, asking you to explain what the next steps might look like, not predicting or prescribing them for you, but it gives you a common framework that everyone in your organization, education or private or public sector, can use for education to get their act together. And then finally, just a note to ask anyone who wants these slides to ask me before they do so. And that, my friend, is what I've got. Did everybody hang up?
Yes, thank you very much, Professor. It was a very informative, interesting explanation. So, is there any questions among the attendees? You can ask. If you have any queries, Professor is ready to answer.
I can tell you that I've been using my personal contacts in the engineering profession, but also since I joined LinkedIn some time ago, whenever I run across professors or practicing engineers or students who are up in the senior or graduate, undergrad or senior grad program, I ask them a simple question. I say, once they connect with me, I say, hi, thanks for connecting. I wonder, what courses did you have available to you in your engineering program to learn about soft skills once you became in the field and practice? What I've gotten so far is mainly none at all, And some say, well, our school started a course at the junior year or senior year level on communication skills that dealt mainly with writing reports, but little to nothing about addressing the need for the understanding in the 21st century that you're working. And these days, as you know, many companies work virtually around the world. And so when you ask somebody, if someone in China and you're coming from America, or they're in Nairobi, and you're asking them, or they're in Italy or Portugal or Greece, and you're asking them a question, if you haven't been previously schooled in what your language means in their culture, you've got a mess on your hands. And many other cultures than American don't hesitate to just agree, get off the phone, and then they're in a total flux of confusion.
Yeah.
Of course, one thing the world faces, and I'll leave you with this, is anyone can answer. What do you call someone who can speak 2 languages?
Bilingual.
What do you call someone who can speak 3 languages?
Multilingual.
What do you call someone who can only speak 1 language? American.
American. Okay.
Yeah.
Professor, there is a question.
Yeah. No, I want to say something.
Okay.
Bill, thanks for sharing this with us. As engineering and educator, I believe I learned a lot from here. I believe our system is trying to take care of those also. We are integrating and the ingredients element into our engineering education. For example, like the capstone design and the courses. And for the undergraduate students, we try to let them have the opportunity to collaborate with each other, and from the both aisle, and from the engineering student, and also from the business student. We constantly, sometimes we have the project like those. You have different students and from the different majors to collaborate with each other. Good thoughts. Thank you.